Hello. This video is all about getting practice with your factoring skills. Once you cover all the basics of how we go about factoring, it just becomes a matter of practicing enough so that you can develop efficiency, speed, and confidence at the process. So complete these factoring problems on your own. Do not use AI. Do not you can have AI do all of them for you, and that's not going to help you. So don't. Then check your answers. Okay. Check your answers and use the video to review the reasoning on any problems that you got wrong. So the intent of this video is not for you to watch this video all the way through, but I will go through each of the problems and you can fast forward through the video to the review of only the problems that you need to see. Now, if you find this practice session helpful, please be sure to give it a thumbs up and subscribe to the channel. It's a little bit unconventional. There's no new material being presented. It's just going over problems so that you can hear and see how they are done if you are having issues with any of them. So here's the set of problems. So it is a decent size set. The problems below are mixed type, meaning there's different, categories that teachers would put factoring problems into. And so these are just kind of all mixed up, and they're also mixed difficulty level. The only exception is like the last two problems. If you look down at the last two, you'll see that they're cubics and they are pushing the limit a little bit, but they can be done with everything that we've covered. Now, once you've worked them on your own, okay, so you're going to pause the video here, work all of these problems out on your own, and then check your answers on the next slide. Go through methodically, check them, okay, and then you may or may not need to keep going, okay? So pause the video here to work the problems out. All right, now here are the answers. After you check your answers, fast forward through the video to any explanations that you need. So just kind of go through, mark right or wrong, and anything that you need to see done out, you're going to fast forward the video, and I'm going to write this at the bottom. Turn your volume up. Okay, and I've done this long enough to know that students will mute the video and just go through and copy answers, and that's not going to be helpful. Okay, you want to hear the explanation, you want to hear the reasoning and the thought process. Okay, so without further ado, you can pause this video anytime you want, check your answers. Oh, I am going to do them on 2 per page. Okay, so if you're like wondering how do I know how fast forward to like go, the first slide will be like problems 1 and 2, and then 3 and 4 and so forth. Okay, so first one's up, x squared plus 9x plus 8. I am going to be using the area model for my factorization, but you can use any method that you want. And if you want to see a review of or a comparison of the different methods, I'm going to put a card right up here somewhere so that you can link over to that. So just take a detour, click over to that, and then come back if you need to. Okay, so we're going to put x squared in the upper left and 8 in the lower right, and then we're going to do 1 times 8, so we do a times c, that's 8, and we're going to look at all our factor pairs of 8, and we're looking for the pair that add up to 9. The pair that adds up to 9 is +1 and +8, so I'll fill that in with 1x and 8x, and now I will GCF factor. Greatest common factor between, we'll go this way, x squared and 8x is x. X times x would give me x squared, x times 1 gives me 1x, x times 8 gives me 8x, and 8 times 1 gives me 8. So all 4 boxes check, and my factors are x plus 1 times x plus 8. Now, the order that you write the factors does not matter. So if you are watching this one because you wrote x plus 8, x plus 1, you got the problem correct. So if you got maybe you got 10 of them wrong, you're like, I got them all wrong and I got them all in order. No, you didn't. Okay, if that's the only thing that's different, that is the same answer. It does not matter what order you multiply in. All right, next one, we have x squared minus 11x plus 18. And of course, we do want to be on the lookout for greatest common factors, okay? And I haven't mentioned it. I said this in an earlier video that I tend not to mention it. The first factor in both of these just has x's, and the last factor doesn't have any x's, or last term. First term has all x's, last term has no x's, so I know that they don't have any in common. And so I'm not even mentioning GCF, but hopefully you are looking for that to see if they have common factors. So we have x squared, we have 18. 1 times 18 is 18. And now we're looking for two factors of 18 that we can get to add up to negative 11. So we could have 1 times 18, 2 times 9, 3 times 6, and I think that's all we've got. The 2 and the 9 is my combination that can give me an 11, and I need them to add up to negative 11, which means I need a negative 2 and a negative 9. Double checking, negative 2 times negative 9, and negative times a negative will give me a positive. Negative 2 plus negative 9 is negative 11. So we've got our two x terms. Greatest common factor between x squared and negative 9x is x. X times x gives me x squared. Negative 2 times x gives me negative 2x. Negative 9 times x gives me negative 9x. And negative 9 times negative 2 does give me the positive 18. And my factors are the base and the height there. That's a 9. I kind of did that a little messy. So we have x minus 2 times x minus 9. Moving on. Okay, so I'm going to change up the color, just make it a little bit easier for people that are fast forwarding through to be able to tell that I've changed the slide. So on this first one here, we have 2x squared minus 14x plus 24. And now I do notice a common factor. 2, 14, and 24 are all even numbers. And if they're all even, it means I can factor out a 2. If I have 2x squared and I factor out the 2, I'm left with x squared. And you could think of this a couple different ways. We have a lawnmower going past my window. They're just going to take a couple passes. There we go. You could say 14 and factor out a 2, what are you left with? Or you could think of it as 2 times what if you were to distribute. 2 times what would give you the 14, and that would be a 7. And then 2 times what would give me 24, that would be a 12. Now we just need to factor the quadratic in the parentheses. So we have x squared and we have 12. I'm going to do 1 times 12 is 12. So we want two factors of 12 that add up to negative 7. We have 1 times 2, 2 times 6, or 1 times 12, 2 times 6, 3 times 4. I like 3 times 4. If they are both negative, they will add up to negative 7. And we just want to double check that we're getting what we want. Negative 3 times negative 4 does give me positive 12. Negative 3 plus negative 4 does give me negative 7. And so that's how we break up our x's. Greatest common factor between x squared and negative 3x is x. X times x would give me x squared. X times negative 3 is the negative 3x. X times negative 4 is the negative 4x. And negative 4 times negative 3 would give me the positive 2. So we have the base times the height, x minus 3x plus x minus 4, and don't forget the 2. The 2 was also a factor. Next one. Now, this is what we call a special case. This is the difference of squares, and this comes from conjugates. So here's the deal with this one. If you've got your x squared and your negative 64, whatever is here had to have canceled out. And so it would be positive and negative of the same thing because they ended up with a 0. Now you can use the area model for this. Okay, you can say, I'm going to do 1 times negative 64, and then I'm going to go and find all my factors of 64. Okay. And what you'll notice though is that if you want them to cancel out, you're going to need the two factors that are like the square root of the 64. And so it would be the 8 and the -8. And that's what would have gone in there. But here's the deal. When it's the difference of squares, it always comes out that way. So if you say what times itself gives me x squared, well, that would be x. What times itself gives me 64? That's 8. And then it's plus and minus, and those two things, the vocab word that goes with them is they are conjugates. And when you multiply conjugates together, the middle part always drops out. Okay, I'm having a sip of water there. All right. Next one. All right, so we have 4x squared plus 9x plus 5, and we do want to check, see if we do have a common factor, but 5 is a prime number, and it is not a factor of 4 or 9, so think, I'm going to get a common factor out of that. Nope, no such luck. So setting up our area model, 4x squared, and we have the 5. And then we're going to do 4 times 5 to get 20. And we're looking for two factors of 20 that add up to 9. And you might know that right off the top of your head, okay? Depending on how comfortable you are with your multiplication, you might say, that's going to be 4 times 5. 4 times 5 will give me 20. 4 plus 5 gives me the 9. But if you need to list them out, you got 1 times 20, 2 times 10, not a 3, 4 times 5, and there it is. 4 times 5 is 20, 4 plus 5 is 9. So we'll have 4x and 5x. I'm going to GCF factor this way because I don't want to deal with the number part. So 4 and 5 don't have a common factor. X squared and x, the GCF would be x. And then this would be 4x, so x times 4x gives me 4x squared. 4x times 1 is what would give me 4x. X times 5 gives me 5x, and then we can check it. 5 times 1 is 5. So with the area model, you can double check each box. Okay, double check each box and make sure everything multiplies out the way you want. And we have a base of x plus 1 and a height of 4x plus 5. This one, no common factors. All right. So again, you notice that we are having kind of a mixed difficulty level here. So we're factoring the 20 again. Okay. So it's the same number that we had there. We're going to do 1 times -20, which gives us -20. Now this time it's a -20 instead of a +20. So this means that we're going to have one positive and one negative, and we'll deal with that once we pick our factors. Now I'm looking for a +1. And so as I sort through this, if they're the same sign here, I would get a 21. If they're opposite signs, I can get a 19. Same sign, I can get a 12. Opposite signs, I can get an 8. Same sign, I can get a 9, okay, which is what we needed over here. Opposite signs though, meaning if one of them is negative, I can get a 1. If I do 5 minus 4, I can get a 1. Now, I do need to get a +1, which means the 4 would need to be negative. Double checking that before we plug it in. -4 times +5 gives me -20. -4 plus 5 is +1. So I'm going to go ahead and put in -4x and 5x, and I'm going to do the GCF factoring this way, just because I'm going to try to avoid the negatives. So greatest common factor between x squared and 5x is x. X times x is x squared, 5 times x is 5x, -4 times x is -4x, and +5 times -4 does give me -20. And so we have the base is x minus 4 and the height is x plus 5. Okay. Ooh, ouch. Okay, so that's my first reaction, and I wrote this wrong. I wrote it earlier today. Lovely. Okay. So the first thing I'm really, really hoping for here is that there is a greatest common factor, because there is no way I want to do 15 times 80 and deal with whatever that batch of factors is going to be. But what I notice about this problem is that 15, 40, and 80 all end in a 5 or a 0, which means that I know for certain that 5 is a common factor. So I'm going to start this by factoring out the 5. We're going to undistribute it. 5 times 3 would give me the 15, and we'll have the x squared. 5 times 8 would give me the 40. And if you need to grab a calculator and do that out, you can do 40 divided by 5. Okay, and basically that's like factoring out the 5 to see what's left over. And then this would be what, 16, I think. All right, still not super happy with that. Okay, yeah, still not super happy with it, but better than a 15 and an 80. So setting up our area model, we are going to have 3x squared in the upper left and negative 16 in the lower right. And then we're going to have to do 3 times negative 16, which is negative 48. Okay, now I'm going to be looking for factors of 48 that I can get an 8 out of. Factors of 48 and get an 8 out of. So that would be 1 times 48. I can get a 49 or 47. 2 times 24. So that would be, I could get a 26 or a 22. Now, is this divisible by 3? Yes, well, I know that because I got the 48 by using the 3. So 3 times 16. But you can also, if you didn't know this, you can add the digits. So add 4 plus 8 is 12, and since 12 is divisible by 3, so is 48. This I could get a 19 or a 13, so still no luck. It is divisible by 4, and I know that because when I divided it by 2, I still had an even number left, which means I could divide it by 2 again. And if you can divide it by 2 twice, then it's divisible by 4. So this would be 4 times 12. And I like that for getting my 8. If I do 12 minus 4, I can get 8. Just to make sure we're not missing anything, though, I cannot divide it by 5, but I can get 6 times 8, and I can get 14 and a 2 out of that. So I'm going to go with the 4 and the 12. I need to get a positive 8, so I'm going to make the 4 negative and the 12 positive. Quick double check before we plug it in. Negative 4 times positive 12 is negative 48. Negative 4 plus 12 is 8. So I'm happy with that. So we'll do negative 4x and 12x. I'm going to GCF factor this way to get this out here because I don't have a common factor between the 3 and the 4. I do have a common factor between the 3 and the 12, which I can factor it that way, but if I've got an option that's a little bit simpler, I'm going to take it. So greatest common factor between 3x squared and negative 4x is x. Then 3x times x would give me the 3x squared. X times negative 4 would give me the negative 4x. And then you can really go with either of these. You just need to get this out here. So you could say 3x times 4 would give me 12x, or negative 4 times 4 would give me negative 16, whichever one is, it makes you happier inside. And so we have our base of 3x minus 4. And our height of x plus 4. And then don't forget your 5. It's easy to forget that 5 that we got at the beginning. And yes, you need all of those pieces. All right, next one, not quite as bad. I don't have any common factors in this one because 3 and 5 are prime numbers and they're not the same prime numbers. So no dice there. So we'll put the 3x squared in the upper left, negative 5 in the lower right, and then we're going to do 3 times negative 5 to get negative 15. And we want 2 factors of 15, or we can get a 14, and I can get that really fast. 1 times 15. If I subtract those, I can get my 14. The only other contending pair we have is the 3 and the 5, and that does not work. To get a 14, the 1 has to be negative and the 15 would have to be positive. Quick double check before you put it in there. Negative 1 times 15 is negative 15. Negative 1 plus 15 is positive 14. So we'll have negative 1x and 15x. And same as before, I'm going to factor this in this direction because I don't have as many common factors this way. So greatest common factor between 3x squared and negative 1x is x. X times 3x would give me 3x squared. X times negative 1 gives me negative 1x. 3x times 5 gives me 15x. And 5 times negative 1 gives me negative 5. So double check all of those. Our base was 3x minus 1. Our height was x plus 5. All right, we are 20 minutes in. Next one. Okay. So this one I'm not a huge fan of, but I do see that there is a common factor of 3. So I know that 12 is divisible by 3. That will give me 4, and 6 and 3 are individually divided by 3. Therefore, 63 is divided by 3. So I'm going to go ahead and get that 3 out of there. So 3 times x squared would give me the 3x squared. 3 times 4 would give me the 12. And what is this? 3 times 21? 3 times 21. All right. So that simplifies everything. We're going to have an x squared in the upper left, negative 21 in the lower right, and we want 1 times negative 21, 2 factors of negative 21 that add up to 4. So we have 1 times 21, not 2, 3 times 7, and that's it. If we need it to be a positive 4, then the 3 would have to be negative. And I'm noticing as I'm doing these that I'm getting the smaller number as the negative number. That is just a coincidence, okay? If this was a minus 4 in the middle, it would be the other way around. And I wrote these problems this morning and basically wrote them all by multiplying them out like at the outset. And this could just be like a pattern to how I tend to write the problems when I'm throwing numbers in there in the first place. So just to let you know, like that is a coincidence. Quick double check. Negative 3 times 7 is negative 21. Negative 3 plus 7 is 4. Got to make sure I go to the right spot on the page. So we'll have negative 3x and 7x. I'll go ahead and factor going up this time. Greatest common factor between x squared and 7x is the x. X times x is x squared. X times negative 3 is negative 3x. X times 7 is 7x. And 7 times negative 3 is negative 27. So our base is x minus 3, our height is x plus 7, and then don't forget we had a GCF at the beginning of all of that. So that factor is out front. Next one, this is another difference of squares. So you'll notice that the B value is 0. So you are welcome to like go through your area model and look for like the things that would cancel out, or you can remember this. To get the x squared, we had to do x times x. To get a 1, we do 1 times 1. And to make sure that they cancel, we'll do plus and minus. So we're going to have those conjugates. And a reminder to you, that is a special case. It's one of the ones where I don't typically recommend that my students use the area model for. All right, what color haven't I used for a while? Let's use this color. Okay, so this one, no common factors. So we'll just go ahead and set up the area model. We have x squared. We have a 42. Everything is positive. I love that. So we have 1 times 42 is 42. So we just need to go find 2 factors of 42 that add up to 13. So let's see what we can find. We have 1 times 42. 42 is even, so this is what, times 21? Yeah, okay. It is divisible by 3, and the reason I know it's divisible by 3, well, I can tell a couple ways that it's divisible by 3. One way is by doing 4 plus 2. 4 plus 2 is 6, and 6 is divisible by 3. Therefore, 42 is divisible by 3. The other way I know it's divisible by 3 is because I ended up with a 21, and 21 is divisible by 3. So you can kind of reason that out a couple of different ways. And I believe that is 3 times 14. So still not getting the factors that add up to 13. 5 is not a factor, but 6 is, and you know that 6 is because 2 and 3 both are. Oh, 4 is not a factor, and I know 4 is not a factor because when we divided out the 2, we got an odd number, which means that there's no other 2's in there. 5 because it doesn't end in 0 or 5, but 6 works because 2 and 3 are both factors, and that's 6 times 7, and that's the one we want. Starting to sweat that one out. Okay, 6 times 7 is 42. 6 plus 7 is 13. So we'll have 6x and 7x. Factoring out the greatest common factor, we get x and x. We get a 6 times x. We get a 7 times x. And 6 times 7 is 42. Base is x plus 6. And the height is x plus 7. This one, another kind of cringy moment, like, oh, wait a minute, am I going to have to multiply 4 times 18? No, because 4, 18, and 8 are all even numbers. So this isn't going to get me perfectly where I want to go, but it's going to get me to a better spot. So I'm going to go ahead and factor out a 2 because I know that all of those numbers have a factor of 2. 2 times 2 would give me the 4. 2 times 9 is what would give me the 18, and then we'd have another 2 times 9. So that shrinks our numbers down quite a bit. We're going to put the 2x squared in the upper left, 9 in the lower right, and our scratch work, 2 times 9 is 18, and we want 2 factors of 18 that add up to 9. 1 times 18, 2 times 9, 3 times 6, there's my pair. If they are both positive, it should work. 3 times 6 would give me 18. 3 plus 6 gives me the 9. So we'll have 3x and 6x, and I am going to GCF factor this way because 2 and 3 are what we call relatively prime, meaning they don't share any factors other than 1. Greatest common factor going this way is the x. X times 2x would give me 2x squared. X times 3 would give me 3x, and 3 times 3 would give me the 9. And then I'll check it with this one. 2x times 3 is 6x. So my base is 2x plus 3. My height is x plus 3. And don't forget, we had a GCF on that one. And you do need to have the GCF. Okay, it affects some problems and not others. It depends on what you're doing with the equation or function expression, whatever we've got here, whatever word we're using. It depends on what we're doing with it. So there are times when you can kind of get away without getting the GCF and you'll still get the right answer. Other times when it will cause something to be wrong. Okay, no common factors here. Here we have all x's and here we have no x's. So we are stuck on this one. We're just going to have to do the work. So we'll have 2x squared and we'll have the -3. 2 times -3 is -6. So I need 2 factors of -6 that add up to -1. 1 times 6 and 2 times 3, it better be the 2 times 3. And we need them to add up to a -1, which means the 3 has to be negative. So I'm glad that one, like it was the larger number, the number on the right, that was the -1 because it just felt like that was like a lot of coincidences. All right. Double checking before you plug them in. 2 times -3 is -6. 2 plus -3 is -1 up there. Just remember that is a 1. So this will be 2x and -3x. And I'm going to factor going this way to avoid the GCF. Or avoid the number part of the GCF. So greatest common factor between 2x squared and -3x is x. And then 2x times x will give me the 2x squared. 2x times 1 gives me 2x. -3 times x gives me -3x. And we really hope that last one checks. -3 times 1 is -3. And so the base is x plus 1, and the height was 2x minus 3. Oh, look at that. Look at those big numbers. Now, there's no common factor here. 37 is prime and 5 is a prime and 14 doesn't. Nope. Okay, so our hopes are dashed that we could shrink these numbers down. So we're just going to go through with it. 5x squared, and then we have the 14. And we need to do 5 times 14. So that's awesome. I'm going to go ahead and do that out. That looks like that is a 70. So we are looking for 2 factors of 70 that add up to 37. And honestly, if you were doing these out, like if it were me, I might like skip this one and come back to it. Not because I can't do it, just because looking at those numbers, I'm thinking, oh, really? So let's just keep an eye out for our factors that might add up to 37. So 1 times 70, no. 2 times 35. Look at that. We got it on the second one. So are there more factors? Yep. We don't need to keep going. I think 5 is going to be a factor there. 7 is a factor, but we don't need them. So let's just double check these. 2 times 35 is 70. 2 plus 35 is 37. So we have 2x and 35x. Now, I'm not thrilled with that 35. So what I'm going to do is try to avoid it. Okay, I'm just going to try to avoid it. So 5x squared and 2x, the greatest common factor is x. So we'll grab the x. X times 5x would give me the 5x squared. X times 2 would give me the 2x. And then what I'm going to do is use this one here. 2 times what gives me 14? That's 7. And then I'll check it with the 35. 5x times 7 is 35x. So my base was 5x plus 2, and my height was x plus 7. Okay, on the home stretch. We are on the home stretch, the last fourth of the assignment here. All right, let's use. So no GCF on that one. So 15 should be fairly straightforward. We're going to have x squared in that upper left and negative 50 in the lower right. 1 times negative 50 is negative 50, and we want 2 factors of negative 50 that add up to positive 5. I can think of what they are, but we'll go through them anyway. 1 times 50, I can get a 51 or 49. 2 times 25, I can get a 27 or a 23, but I'm looking for a 5. 3 is not a factor because 5 plus 0 is not divisible by 3. 4 is not a factor because when I divided it by 2, I got an odd number. 5 is, though, because it ends in a 0, and I would get 5 times 10, and I can get a 5 from that if the 5 is negative and the 10 is positive. So negative 5 times 10 is negative 50. Negative 5 plus 10 is positive 5. Now, 6 is not a factor. 7 is not a factor. 8 is not a factor because 4 is not. 9 is not a factor because 3 is not. And therefore, we know we've got all the factors there. So we'll go and put in the negative 5x and the positive 10x. Greatest common factor, we'll factor this way. X squared and 10x would be x. X times x is x squared. This is negative 5. This is 10. 10 times negative 5 is negative 50. So my base was x minus 5, and my height was 10. X plus 10, sorry. All right, number 16. So this one, I would love to have a GCF. But 11 is a prime number, and 6 and 5 are not factors of or multiples of that prime number. So, okay. But we can do this. We've done some challenging ones, hoping for a GCF there, but you can't win them all. So we have 6x squared, and then we've got the 5. And then we need to multiply those. So 6 times 5 is 30. And we're looking for 2 factors of 30 that add up to negative 11. So 1 times 30, 2 times 15, 3 times 10, none of these can get me an 11. 4 is not a factor because 15 is odd. And then 5 times 6, and I can get the 11 from those, which is kind of where I started from, but they would both need to be negative. If I need them to add up to negative 11, they would both need to be negative. And so we'll double check that before we plug them in. Negative 5 times negative 6 is positive 30. Negative 5 plus negative 6 is negative 11. So I feel pretty good about this. Negative 5x and negative 6x. Now, right here, 6 and 5 don't share any factors. So the greatest common factor between x squared and x is x. And then this would be 6x. Times x would give me the 6x squared. X times negative 5 gives me negative 5x. This one is a little bit weird. 6x times what gives me negative 6x? It would have to be a negative 1. And negative 1 times negative 5 does give you a positive 5. So it's like a little bit slick there. My base was 6x minus 5, and my height was x minus 1. Okay. All right, now this one is kind of interesting. So I'm actually going to work this one out 2 different ways. So what you've got there is the difference of squares. 4 is a perfect squared, x squared is a perfect square, and 100 is a perfect square. So you've got, looking at that, you've got like 2 squared x squared minus 10 squared. And so one of the ways you might do this is you might say, okay, well, that is the difference of squares. And so 2 times 2 would give me the 4, x times x gives me the x squared, 10 times 10 gives me the 100, and then 1's a plus and 1's a minus. Here's why that's not considered correct. Because each of those factors has a common factor in it. 2 and 10 are both even, and so they have a common factor of 2. So what you need to do is you need to factor out a 2 from this parenthesis right here. So if I factor a 2 out, 2 times x, remember if you were to distribute it, you get 2x, and then this would be 5. But there's also a common factor over here in that set of parentheses. So we can factor 2 out from there as well. And now remember that this is all multiplication. So this is 2 times x plus 5 times 2 times x minus 5. And you can multiply in any order that you want. So I'm just going to go ahead and like just switch those two. So I have 2 times x plus 5 times x minus 5. And the 2 times 2 is 4. And that would be your complete factorization. However, remember, we get lazy about this because we just kind of jump to stuff. What we really want to do is factor out a GCF at the beginning of the problem. And so what we really would like to do there is recognize that 4 is a factor of 100. So I'm going to undistribute that at the beginning. So 4 times x squared would give me 4x squared. 4 times what would give me 100? That would be 25. And now you've got the difference of squares, but you've got it with much smaller numbers. So you could set up your conjugates, 1 plus 1 minus. X times x gives you x squared, and 5 times 5 gives you the 25. And then don't forget your common factor of 4. Okay, so pause here just like for a moment, pause the video and look at the 2 solutions. Okay, they both get you to the same spot. So if you did it the first way, you didn't do anything wrong. If you stopped before it was fully factored, you want to make that correction to your work. And then notice, like make a little note, like this would be easier if I found the common factor at the beginning. And you can do this with anything that has a common factor. So if you factor it out and then you get to the end and the end has, like you see what we see here, where there's a common factor in there, you need to be able to factor that out. All right, next one, 15 and 4 do not share any common factors. So no dice getting a common factor there. So we're going to put in the 15x squared and the negative 4. And we're going to do 15 times negative 4, which is negative 60. And I cry a little in my heart because this video is 40 minutes long. And while you might be fast forwarding through the problems, I'm not. So it's getting very long. Okay, so and I think I got a factor negative 60, really? So 60 has a lot of factors. We're going to keep our eyes open for a pair of factors that will add up to a negative 4 I could get a 4 from. So we've got 1 times 60, nope. 2 times 30, no. 3 times 20, still no. 4 times 15, nope. What do we got? 5 times 12. Now I'm getting closer. Like with the 14, with the 4 and the 15, I can get an 11. And with the 5 and the 12, I can get a 7. So I'm like getting down like closer to where I could get a 4. It is divisible by 6. Because it is divisible by both 3 and 2. And 6 times 10, oh, thank heavens, like 10 minus 6, that would give me a 4. It's not divisible by 7. It is not divisible by 8. And I know that because when I factored out a 4, I was left with an odd number, so I couldn't get another 2 out of it. And it is not divisible by 9. Because when I took out the 3 and I look at the 20, there's not another 3 factor in the 20. So not 9, and then 10, we're back to where we started. Now for this to come out to negative 4, the 6 would be positive and the 10 would be negative. So quick check. 6 times negative 10 gives me negative 60. 6 plus negative 10 gives me negative 4. So we'll do 6x and negative 10x. And on this one, I can't avoid a common factor with the number part. Okay, I can't. Now all the other ones, like I've tried to avoid it. It's like, can I figure out a way to do this so that I don't have to tangle with the numbers? And I can't here. So you do have to think, what is the GCF? Like the two x's are going to break up. But what is the greatest common factor between 15 and 6? So looking at that, 15 factors into 3 times 5, 6 factors into 2 times 3, so they share a factor of 3. So this would be 3x, and then I can do all the rest by multiplication. So to get that 15, that must be a 5x. 3x times 5x would give me 15x squared. 3x times 2 would give me 6x. And then I'm going to deal with the negative 4. So 2 times negative 2 would give me negative 4. And then I'm going to check it with the 10. So 5x times negative 2 is negative 10x. So I feel pretty good about this one. My base was 5x plus 2, and my height was 3x minus 2. That one's a little bit more challenging because both of the factors have what's called a leading coefficient. And like some of the simpler ones, like you don't have a leading coefficient, or the leading coefficient is 1. You see that. And then when you have like one of them has a leading coefficient, the other one doesn't, that's like kind of a middle level of difficulty. And then when you have both of them, that's going to make your numbers bigger and just makes it more challenging. So, but not too bad. Like the worst part was like breaking down the 60. Now, these two are meant to stretch you a little bit. Like they are meant to see like, what can you do with this? So number 19 does have a GCF. So I'm going to go back to some of that GCF, like basic work that we were doing. I'm not going to break it down all the way. I'm going to break this down to just 2 times 16. And the reason I'm not going to break it down into the prime factorization is because I know I only have the 2. So like once I find the common factor of 2, like I might as well just leave the 16 alone. So these guys have a common factor of 2, and they also have a common factor of x. And so when I go to factor that out, the 2x will be the common factor, and I'll be left with x squared minus 16. And then we want to recognize, oh, that's one of those special ones, like special cases. So x squared would break down into x times x. 4 could come from doing 4 times 4. 1's a plus and 1's a minus. So remember, that's your conjugates. And if you're not sure about that, you could go and multiply them back together. But what you're going to get is a 4x and a negative 4x that are going to cancel each other out. All right, and this last one, yay, almost done. Okay, so we're going to go ahead and do some prime factorization on this one too, just to break it down. So 6 breaks into 2 times 3, and this is x times x times x. 15 is 3 times 5, and then we have a couple x's, and then 9 is 3 times 3, and we have an x. And looking for our common factors, all of these have a common factor of 3, and all of them have a common factor of x. So I'm going to take that 3x, that's my greatest common factor, and I'll put everything else back together. So we have 2x squared minus 5x minus 3. And now I've got to factor what is left in those parentheses there. So 2x squared and negative 3. And come over here for my scratch work. 2 times negative 3 is negative 6. And we want 2 factors of negative 6 that add up to negative 5. Now we need to be very, very careful on this one because we have 2 potential combinations of things that could work. My factors of 6 are 1 times 6 and 2 times 3, but both of those can give me a negative 5. If I have a positive 1 and a negative 6, positive 1 times negative 6 will give me a negative 5, okay? But I could also have negative 2 and negative 3, because negative 2 plus negative 3 would also give me negative 5. And this is why all through this video, right, I have been like double check both of those things. Just kind of run a quick double check, because both of these work for the negative 5, but they won't both work for the negative 6. 1 times negative 6 gives me negative 6. That is the one I want. Negative 2 times negative 3 will give me a positive 6, and it actually will not work. Okay, and so that's why for every problem, I do a quick little double check this, make sure it works for both. Now, there's not tons of times when that happens. Okay, I think it's 2 that are fairly you're likely to see, and then 1 that's a little bit rare. And I'm sure there's more, it's just you're not likely to see them. So that's why I always do that quick double check. All right, so what do we have going in here? We have 1x and negative 6x. GCF going across here, 2x squared and 1x is x. 2x times x gives me the 2x squared. 1 times x gives me 1x. 2x times the negative 3 gives me negative 6x, or 1 times negative 3 is negative 3. So my base is 2x plus 1. My height is x minus 3, but don't forget we had a GCF. Ooh. Now that is, so I'm going to tag this video for Algebra 1 and Algebra 2 because this content legitimately doubles up. This is actually really pushing an Algebra 2 level of difficulty. It's totally covered in the content for Algebra 1. It's just not super common to see one like this in Algebra 1. It's a little bit more common to see it in Algebra 2. So, all right, so there we go. That took me, the timer on this recording is 47 minutes, and I don't remember what the timer was when I started going over the problems. But if you found this video helpful, okay, so if this kind of mass review, gave you a bunch of problems, please give the video a thumbs up. It lets me know that this kind of video is helpful. Subscribe to the channel if you haven't, and take a moment and check out some of the other resources on factoring. So if you don't use the area model, if you use slide and divide or factoring by grouping, we have a video that compares the different methods so you can connect them. Factoring with algebra tiles, you can do all of these problems with algebra tiles. It's pretty awesome, except maybe the cubics. And we have some videos where you can learn how to check your answers on Desmos or check your answers with the graphing calculator. So you might find any and all of those videos helpful. I'll try to link one of them below at the end of this video. Thank you for tuning in and hanging with me, and I hope to see you in a future video.